Okay, the last time I was working on this, I made this part. I 3D printed this part. This is the part that sits on top, and it's going to rotate. It's going to be a 6-inch diameter aluminum plate that's going to rotate on top of this part. So what happened was I got the diameter of the gear off of the website, but the diameter of this gear was made for a belt to run on the inside. But I'm using the belt on the outside. So what happened was that the pitch diameter changed, and the belt was not correctly going into the teeth. It was skipping. So I reduced the number of teeth by 2. And rather than print this over again, because this took 6 hours, I printed one with most of that. I put a big angle on here, well, 45. Took away this chamfer, took away this edge, put a 45 in there, took away the holes, made the plate a lot thinner. I was just making a demo. All I was interested in was the teeth. I wasn't really interested in the outside of the part because I knew I wouldn't be able to use it, because this is just to get the teeth right. If I didn't get the belt to fit in the teeth correctly, the part doesn't do me any good. So I reduced the number of teeth by 2, and it worked out great. Fits in there, everything's good. So I went ahead and printed another part, just like the first one. This is the first one. This is actually the third one, because I printed this one as a test piece. So this one came out good. It's got the right number of teeth. The belt meshes with the teeth correctly. I put the holes back in it, made the thickness correct. Everything's correct on this part. So it's basically good to go. So then I started printing the actual unit itself. Now this is it cut in half, because I have to print half at a time. I have to take the whole unit, which is, if you think of a beach ball or a ball, that's what this is going to look like when it's finished. So this is half of the ball from here over, but it's not finished, because during the process of trying to finish this part, now these things in here, that look like honeycomb. Well, these are a bigger honeycomb, but that's what the 3D print. So it's not printing a solid piece, it's basically honeycomb. Now these pieces here, it prints these as what do you call them? when you got a flat shelf, it has to print these supports. They call it supports. So these are supports because there's going to be a flat piece on the other side. And that's what these are, supports. I got a big one over here too. This is where the motor goes, in here. You take out this support, there's a flat piece on the underside, and the motor's going to go in here. This is half of it. This is where the bearing's going to go for the pulley. And there's a bearing that goes in this hole too. I know it's you know, when you're first looking at this, it's really hard to understand what it is, but I didn't get anyway, the point is I didn't get to finish it because when I first started this part, it's like a 20-hour, 22-hour runtime on the 3D printer. And when I first started this part, I was getting a lot of problems with it sticking to the glass surface. And ultimately what I found out was that the nozzle was, I won't say the nozzle was clogged, but the area around the nozzle, there's a heating element that this nozzle screws into. It's a block, and there's wires attached to it, and it heats up. And the whole unit was full of residue plastic from the PLA, the plastic I used to make the parts. It was a lot of residue around there, and it was dripping, and it wasn't allowing the stuff to flow through here and the rest of the chamber. There's a heating element in there and stuff, and it was a maintenance issue, and I didn't know that, you know, you had to do anything down there to clean it, because, you know, this is the first machine I've had, and I haven't had it that long, but I've used it quite a bit, and I noticed that on my other parts I was getting like these globs, and that's what was happening, was that the plastic that goes through this nozzle, I guess it collects on the nozzle and it oozes out. It's like the oil underneath your car. You know, if you get a little drip or something, it just gets all over the underside of your carriage. And that was what was going on. It was just a maintenance issue, and I didn't know anything about it. So anyway, I took it apart and I cleaned it. I cleaned the heating element and what have you, and cleaned everything and put it back together, and the thing worked great. So I started it up and let it run, and it ran for, I don't know what it was. It was, I don't know, about 16 hours. And I was outside doing some stuff, and I come back in, I hear this clicking noise. And what was happening was that the plastic was trying to feed into this nozzle, and it wasn't coming out. So the little gear that drives the plastic was slipping, and it was making this clicking noise. So I used a pause print, and it moved the head away, and I took the nozzle back out, and it wasn't that bad. I mean, it was clean. Everything underside looked clean. And I tried to pull the plastic out of the tube. It rides in a tube. They call it a boron tube or something like that. But this is the spare one that they gave me. They gave me spare part. And this is the tube that it rides in. And I noticed that before, you know, this is the little piece that the tube fits into. The tube, this piece screws on top of the heater element, and then this thing goes into it, and it goes down, and it fits flush with this. Well, it's the metering jet. It's a nozzle. This is a 4mm. It's got a little hole in the end, and it's 4mm. But anyway, I noticed that, you know, if you push the top of this down, the tube should come out. And I noticed before that I was having trouble with it. You push it down and you can't get the tube out. The tube wouldn't come out. So I was looking, you know, I saw before, like on the different videos for these printers, that they don't take the tube out of this piece. What they do is they loosen this nut and they take the whole thing out as an assembly. So I cleaned out the nozzle, and I pulled the plastic back out, and I tried not to, you know, I wanted to resume print, so I couldn't disengage it from the program. I just basically hit the red button, you know, to stop it, and then I wanted to hit the green button to make it go again after I cleaned it, or trying to find out what was wrong with it. And anyway, ultimately what I found out was that I pulled the plastic out of the tube a little bit to clean the nozzle and everything. Then when I tried to put I put resume print, and I pushing the plastic back into this tube to make it go through here, to make it go through the unit, and I couldn't get it to go. It wouldn't go. It wouldn't push through the tube. And I thought that was strange. So I hit pause print again, and for some reason the unit canceled the print, and I wasn't too happy about that because you know, I only had like 4 or 5 hours to go, and I could have finished this one part. So anyway, what I ultimately found out was that this thing, which screws on top of the heater element, it gets hot. It gets warm. And inside of this thing, you push that down, they got these little fingers. And what they do is when you push that down, it releases the fingers, and it allows this tube to move. And then when you release this piece on the top, it pushes those fingers back down, and it pinches on this tube. So what was happening was, when this was getting warm, those fingers inside are metal. I have a bigger one here. But anyway, those little fingers inside, they were clamping down on that tube, and ultimately what they were doing was they were squishing it. Well, anyway, there's metal fingers in there. So they were squishing the tube, and the tube was getting choked. So the plastic wasn't going through. You couldn't push it through because the tube was collapsing from the fingers pushing on it, because it was getting hot and it was melting the plastic, collapsing the tube, and then the plastic wouldn't go through. So that was ultimately the problem. It wasn't the nozzle. It was the tube. So what I did was I just, since the nozzle rides somewhere around here, about that height from the bottom. So what I do is I cut a little piece off the bottom, so that the tube would slide down a little bit so it would be in a different area. Instead of replacing the whole tube, all you have to do is just cut a little piece off the bottom so that this rides in a different area on the tube where the nut is. And then the other thing was you could just take the tube out and reverse it. You could, the other end, it rides on the very end, and that way this piece over here is not compromised, as to where over in this area, this is where the fingers pull down on it and it gets pinched. But that isn't, I mean, that was the cause of the problem, was that this is on top of the heater unit and it gets hot, and those fingers get hot and it collapses this tube. So that was the problem. So what I'm thinking about doing is I'm going to take, I got these, what are these, 6mm or 8mm? 6mm? I don't know. I had these from something from the other unit. Yeah, these are, I don't know, 8mm. So what I'm thinking about doing, I'm going to take this one out of brass, and I'm going to cut it. I'm going to cut it. I'm going to take the piece off the end and the fingers out. See what happens here is that they pinch it right here where the neck is. They install the components and then they pinch it, and that's what collapses all the parts onto this unit. In this area they pinch it. Same thing with the small one too. Right here on this area. It's like, you know, when they take a hose and they put a hose barb inside of it and they put the ring around it, they pinch it to collapse the outside of the hose onto the inside. So what I'm thinking about doing is I'm going to cut this, take the guts out of it, put an extension inside of here. Now see, it would be easier to make a new one, but I can't make these threads. I can make the female with a tap, but I don't have the thing to make the male threads. So I'm going to take this unit, I'm going to cut it right there, put in a lathe and take a little parting tool and just go in there until that piece breaks off. Then make a brass piece to slip inside of here with a thread on the other side using the tap. It's a pipe tap. And what I'm trying to do is this piece that gets threaded into the heater unit, I'm putting a little extension on here so that the heat can dissipate by the time it gets up to here. I'm thinking maybe 3/4 of an inch. I don't know if I can go 1 inch, because what this piece does is it holds that tube in place. Now there is no real seal down here. I mean, the whole object of this piece is to keep that tube from backing off once it's inserted inside that heater unit. So it doesn't matter if this piece is down here or up here or even further, so long as it captures that tube and keeps it from sliding backwards. Now I'm going to try to, on the inside of this, I got to make it fit this tube fairly snug, so I'm going to put a little bushing inside to capture this tube, because that's what this one does. It's got the pretty snug hole on the end to capture the outside of this tube. But I mean, you don't really have to make the extension to fit on there. But you know, I just want to avoid problems later on, because you know, when I'm running this unit, you know, if it's a short run, I don't think it's an issue. But you know, when you're running, I got to run these parts, and it takes almost 24 hours for each half. You know, I got to make sure that this thing, you know, is as flawless as possible, because I don't want to have to stop and do this all over again. This is what's going on here. Now I got to make this part over. So the other thing I looked into was these nozzles. Now these nozzles are 4 millimeter, and I looked into I ordered 4 more of these, or 5 more, just to have them on hand, and I ordered some 6 millimeter. Now the 6 millimeter is going to give a bigger wire, you know, a bigger I don't know what you call it, path for the wire. When the plastic melts, it's going to be 6 millimeter instead of 4 millimeter. So it's going to lay down a bigger bead, I guess you would call it. And it's going to be a little rougher finish, but this, you know, the finish on here, it doesn't mean anything because it's just on the outside. The only thing that, you know, I really care about is the finish for the bushings I'm going to put in here that the pulley is going to ride on. But since I'm going to put basically a bushing in it, you know, it doesn't matter what the finish is, because when I put the bushing in there, the bushing is just the seal. The outside of the bushing is going to hit on here, and then the inside is what's going to ride the gear. So it doesn't matter if it's a little rougher, so long as it gets finished. And with the bigger nozzle, there's they said less chance of it clogging, because it's going to flow more fluid. It's going to flow more. But anyway, that's what I'm going to do now. Well, not now. I've got to wait for the parts to come in, but it looks like we're getting there. All right. Talk to you later.